anything we have already done, if you click right here for the archive lessons, it will bring up a sheet and I'll bring up all the links to what we've already done. So like I'll put a link to, I may even put a link, I don't know if I'll put a link to today's Zoom, but I'll put the Zoom in up for you guys on the updates. And then like today's lesson, so if you click this, it's gonna take you right to where we would be in Schoology today, which is the graphing folder. So it just takes a second. All right, so today, what we're gonna go over is, so remember I was trying to get you guys to finish up work that you hadn't done, which some of you still have not done. So when I put in those zeros this week, please do not send me messages begging me, can you do your get to know you form that took you 2 or 3 minutes to do that I gave you 2 weeks ago?
Ms. Payne.
Yes.
You said I didn't do the flip grid, but like I checked and it said I did it. And I didn't know if I did it wrong, but I couldn't figure out how to do it differently. So.
Okay, at the end of class, I'm gonna go through, I haven't updated Flipgrids since the weekend, since maybe Thursday. So I'll go back and look and then everybody can just kind of sit on the line if they have questions about stuff.
All right.
So I'll double check that. So, but yeah, so make sure you get, cause I'm putting in grades probably starting tomorrow. So if you don't have something done, you don't have it done and it's a 0 because we've had like 2 weeks. I've been going really, really slow. Like we haven't had anything super hard yet. So you just have to make the most of your time. So today we're going to talk about graphs, but typically if I had not had you trying to catch up on work, you would have already watched the video where it says graphs. You would have just gone in there. There's a video. Okay. You would have gone in there, watch this video, and then today we would have talked about it for maybe 5-7 minutes, however long, if people have questions, and then you guys would have just been working, okay? But since I didn't really ask you guys to do it, then we're gonna talk about that today. And then we're also gonna talk about accuracy and precision. So we're gonna go through all of this today. This accuracy and precision notes, these are, it's a Google assignment, but it's just your notes. So I realize I need to be more diligent about making sure you guys do your notes. So if we were in class, I would be giving you notes and you would be filling them in, but we're not, so it's kind of weird. So these are notes that you can fill in. You can do it however you want. So you can fill it in on Google. If you want to watch me do it and just take notes on a sheet of paper, that's fine. And then you can go back and fill them in on Google, whatever works for you, okay? But these are the notes. So when I get ready to switch to accuracy and precision, I say, hey, if you want to pull up your notes, now's the time to do it. Or if you want to do it now and just put in another tab, then this is what you'll be pulling up, okay? The graph notes, I'm going to go over them, but then I just did a PDF and put it here just because I didn't give you any graph notes, okay? This quiz is due on Wednesday for you guys, okay? And some of you still have not done the quiz that's due tonight, which is in the scientific notation folder, okay? So I'll send a message probably as soon as we get off saying, don't forget your scientific notation and variables quiz is due tonight, okay? And I think I gave you 2 attempts at it and it takes the higher grade. All right, so let's go to, yes, Eric.
It won't let me open up the graph notes.
Okay.
It says accounts.google refused. I'm not sure if that's just on my side or.
Are you saying this right here, you can't open this? Is that what you're saying, you can't open?
The accuracy and precision notes.
Oh yeah, so I don't know what was going on. Some people were able to open and some people weren't. So just take some notes today and then will you hang around afterwards so I can see what your screen looks like? Because I had like 1 or 2 other people that said that and I don't know what it is.
Yeah, definitely.
Okay, thank you.
Okay.
All right, so I'm going to switch over here. We're going to talk about graphing, and the more you guys participate, the more that we can push forward. In other words, we don't just sit there. So, and I will be calling on people today, so it doesn't matter if your video is on and off. I'm probably gonna call on just about everybody, so. All right, here we go. So I'm going to make myself the host. All right, and then here we go. All right, so you should be seeing good. All right, here we go. So, all right, graphs. So if you are looking at this graph, what information can you tell me or can you not tell me about it? Like, is there good things about this graph or bad things or what?
They're not labeled.
All right, what's not labeled? Yeah, there's a bunch of stuff that's not labeled. Give me one thing that's not labeled, Annis.
Probably what like the blue and pink things are.
Very nice. I have no idea what this blue and pink thing is. Maybe it's girls and boys. Maybe it's elephants and giraffes. Maybe it's apples and oranges. I don't know.
It doesn't add up to 100.
Say again?
Like it doesn't add up to 100. Like, you know, like some stats, they don't, you know, they add up to like the 100% of what they're like trying to estimate or show. And
Right.
It doesn't add up to that.
Okay. So that's a good point. And I want you to remember that because I'm going to talk about a graph in particularly that has to do that. So hold on to that thought, Whitney. But yes, we don't even know, and we don't even know if it's on this particular one, if it should add to 100, because we don't even know what, like this stuff over here, I don't even know what this is. Let me go back and finish what Annis was saying though. So usually you would have either some type of label here, lions and tigers, or you would have something that we call a legend, right? And so if you have a legend, okay, it would tell you, hey, the pink one is this, and then the blue one is this. And we don't have that. So we don't know what the pink and blue stuff is. That's what so Annis was saying. And then Whitney was saying, this doesn't add up to 100 on the side, and maybe it should or maybe it shouldn't. There is a graph in particular where it has to, but we don't even know what this is. Like this 40, 30, 20, is that inches? Is it feet? Is it pounds? Is it years? We don't know what that is. Who knows what that axis is called? The one that's going up and down.
Y-axis.
That is the y-axis, okay? So we have no label on y-axis. We don't know what it is. No label, and we also don't have, we have no units, right? So maybe it would be okay if this said, you know, if this said pounds next to it or something, but we don't even know what that is, okay? All right. What else? What else is good or bad about this graph? Probably bad more than good.
It doesn't label what it says. Like, it doesn't have, like, you know, where the measurements are, like where the numbers are. You have like this amount of students said this, and then you have what you're testing at the bottom.
Right, exactly. So just like we don't have any labels on the side, we also, we don't have any labels here. So let me write this in black still. No labels. What axis is this?
X.
Yes.
X.
No label on the x-axis. So I don't know what that is. 40, 20, I don't know. I don't know what that is. All right. Fisher, if you picked up a book or you looked at this, even if you didn't know what the pink and blue stuff is, What's the first thing you typically read on something?
The
What if you picked up a book? What would be the first thing you read?
title.
Yeah, the title.
The
There's not even a title on this. Look, I don't even know. At least if you're not going to tell me what the pink and blue is and not going to give me labels here, at least tell me what the title is. Okay, I have no idea what the title is of this graph. Okay, maybe it's how fast lions and tigers run. I don't know. And so maybe this is, you know, for all I know, this could be miles per hour, and this could be the animal down here. I don't know. We have no idea, right? But that's why you need all those labels. So I do want you to write this next part down, okay? So we know that if you're gonna do a good graph, you need a title, you need a legend, you need to know your x-axis and your y-axis. Now, let me tell you, when I was in school, my teacher would give me some information, and then she would say, all right, go graph it. And I'd be like, okay, which number goes here? Like, what if they're both numbers, right? What if you have like years, which are numbers, and inches, which are numbers? I don't like which one goes on which side. So I'm going to show you a shortcut to know which one goes on which side. So make sure you write this down. It's called dry mix. Dry mix. All right, dry mix. So last week we talked about a bunch of different two variables in particular. Dominic, what was one of the variables we talked about?
I'll tell you now, I zoned out for like 10 seconds.
It's okay. I'm just asking, last week when we were talking about the variables, what was one of the variables that we talked about?
Let me look through my notes. I don't remember.
Okay. So there was two big ones. One we changed and one we measured. Do you want me to come back to you?
Yeah.
Okay. Jamie, do you remember one of the variables that we talked about last week?
I'm gonna be honest now.
Nobody remembers one of the variables we talked about? We did this all last week.
Are you talking about like
Independent.
Independent.
Yes.
Oh, that stuff? Oh.
Yeah, I'm not trying to make it difficult. Thank you. And I see yours too, Faith. Yes, independent and dependent. All right, so let's write where the D is. We're going to write dependent. Okay. And then where the I is, we're going to write independent. Now, remember, I was telling you a shortcut to remember to where to put them. All right, Dominic, this is your chance. So now that we got the variables, and this is a shortcut to know which axis it goes on, okay? Either X or Y. Do you want to tell me which one the dependent or independent goes on? Take a guess based off of what I wrote down.
Well, you put dry mix, so I'm going to assume that the Y means Y axis and the X means X axis.
You are correct in assuming that, sir. So Y axis for the dependent variable, all right, and X axis for the independent variable, all right?
Yeah.
Everybody getting this down? Okay.
Mm-hmm.
All right, so we just have this M and R, which is like, what? All right, so the M just means that the independent variable is the one that gets manipulated, which is just a fancy word for this is the one that we change, okay? So remember, it's like, are you listening to music or not? Did you put dimples in the car or not? Did you add no sugar, 2 scoops of sugar, 3 scoops of sugar, or 4 scoops of sugar, or none? So that's the thing that gets changed. It just sounds weird if I say dry 6 with a C. So I put M for manipulated, okay? All right. And then the R means it is the one that responds, okay? Which is, this is the one that we measure, all right? In other words, when we change the independent variable, the dependent variable responds to that change, right? if I listen to music or not, my grades respond to that change. If I add sugar to my drink or not, the sweetness responds to whether I put more sugar in there or not, okay? So this is the shortcut. It is on your quiz, so please remember this, okay? So dry mix, okay? Dependent goes on the y-axis, independent goes on the x-axis, all right? Any questions about that? Okay, very good. All right, no. All right, so let's see. Deuce. All right, so if you're looking at this graph or chart, could you guess what type of graph this is? Do you know what this one's called? That'd be you, Brandon. You told me to call you Deuce, right? Yes. You know what type of graph this is.
You said Deuce, you threw me off track.
Okay, that's what you told me to call you, right?
Yeah, I did.
Do you know what type of graph this is?
Bar.
It starts with, what'd you say?
Is it bar?
Yeah, it is. Good. All right, so this is a bar graph, right? Bar graph. All right, so I do want you to know some of the types. So if you see the little stacked columns, that's a bar graph. And sometimes you'll see a bar graph and it looks a little different. It'll look like this. It's the same thing except for the bars are coming out to the side. Okay, so this is also a bar graph. We just call it a stacked bar graph, but either way, it's still a bar graph, but they just come out to the side, okay? This is also a bar graph. So these are bar graphs, okay? All right, so here's—
What is the M for dry mix?
What's the, say again now?
The M.
Manipulate it.
Okay.
All right, so
For the horizontal bar graph, would the X and Y axis like have to change spots?
no, they still stay the same. So if you want to make a note, Y is always going this way. It's the up and down one. And then the X is always going left to right. And that doesn't change no matter what. Okay. Good point. Thank you. All right. So we have bar graphs. We're going to talk about different types of graphs now. We got a bar graph. All right. And so here's another example of a bar graph. This one looks a little bit better. At least I have a title. Anybody remember what I said this was called? Starts with an L.
Legend.
Yep, it's a legend. So you do have a legend. You got a y-axis. At least you know it's percents, but you still don't know percent of what. And you still don't have an x-axis down here, but it's a little bit better than the first one we did, okay? All right, now this one down here. Oops, sorry. Trying to erase stuff from last class. All right, this one. I'm waiting on my screen to catch up. There we go. All right, this one I want you to make a note of. This is the most common graph in science. Okay, this is the one we use the most. Okay, we use this one the most. All right, any guesses for what this is called? It's actually really kind of a simple name. What is this little doohickey right here, or this one?
Line.
Yeah,
Graph.
exactly. So this is a line graph. Okay, this is a line graph, all right? So line graphs are the graphs that we use the most in science, all right? And they just show a relationship. Like, once again, I don't have a title, but whatever it is, I know that this is a percentage, right? I can tell that that's a percentage. And I don't know what I don't know what this blue line is, and I don't know what this blue line is, but whatever it is, as the years increase, so I'm assuming these are years, as the years increase, I can tell that the percentage also increases, okay? And so that's why we do a lot of line graphs, because in science, we're looking for a lot of connections or patterns or trends. So we want to see, right? If this is the independent variable over here, we want to see what happens to the dependent, or what happens to, did I say that backwards? Look, dry mix, okay? If this is the independent variable down here, I want to see what happens to the dependent as the independent changes, right? So as the years change, the percentage goes up. That's all we're looking for, okay? All right, so what I want you to remember about this one is, it is the most, sorry, I did not mean that, I meant to highlight, most common graph in science, and that's the line graph.
Do we have to turn in these notes?
No, you don't have to turn in the notes, but you'll have a quiz over it, like a homework.
Right.
Yeah.
All right.
All right, and I'm gonna post these so you can look at them. But remember, the more that you listen, well, I said listen, the more you listen and you see it and you write it, the more likely you are to remember it, okay? All right, so we got line graph, and then there are some other graphs, like for instance, over here, this is anybody know what this one is? It's kind of a long word. It starts with a S. C-A-T-T. This is a scatter plot, okay? So a scatter plot is a type of graph. I thought that said, this actually says BMI, okay? And then this says resting heart rate over here. Resting, in case you can't read it. Now, what I like about this one is they do have an X and Y axis. What I don't like is that they don't have units. So I usually like to see some units. Like, I'm assuming resting heart rate, I'm assuming, I could be wrong, but I'm assuming this is beats per minute. Beats per minute. You don't have to write this. I'm just telling you, when you have a good graph, you should have a unit, okay? And you should have a unit down here too, body mass index. Sometimes you'll see a scatter plot and you'll see this random line drawn through the center of it, and it's just called a best fit line, okay? You don't have to know that, but sometimes it's just trying to see where do most of the plots fall, okay? All right. All right, so that's a scatter plot. So far we talked about bar graphs, line graphs, and scatter plots, right? So now I'm going to come back to earlier, Whitney was saying, if you look at some of the graphs, some graphs, shouldn't they all add up to 100? And she's right about that, okay? And it's not all graphs, but there is one graph in particular where if you look at it, it should all add up to 100. Any guesses? It's also a delicious dessert, if you like dessert.
What about pie?
Say again?
Pie?
Yes, it is. It is the pie chart. If I'm going too fast, remember, just write something in the chat or just raise your hand, okay? But I am gonna put these up. They're actually already up, okay? All right, so Anna said that this is a pie, you may hear it called a pie chart or a pie graph, either way, pie chart or a pie graph, okay? And this one is really good for showing you parts of a whole, okay? So a pie chart or a pie graph shows you parts of a whole. All right. And then Whitney, what did you say it should all add up to?
100.
Should all add up to 100. So let's check. All right, this is 20. Plus 20 is 40. Plus 25 is 65. Plus 5 is 70. Plus 30 is 100. So yes, perfect. Okay. So, and you don't have to draw this. You can just take little notes. Remember, I have the sheet on Schoology for you. All right, so this is a pie chart. It is known for showing you parts of a whole, okay? And you can have it like this. I'm gonna switch right back to this. I'm gonna switch over just for a second. Or maybe like this. So here, at least they still have, you know, the green is pepperoni, the purple is cheese, the orange is sausage, the like burgundy color is supreme, okay? And they still have the percentages on there, okay? And if I add them up, 20, let's see, 50, 75, 85 plus 15 is still 100. So yes, good, okay? All right, questions so far? I'm gonna put this back right here. Any questions thus far? Okay. All right, Leilani, could you tell me what type of graph this is?
Bar graph.
Bar graph, very nice, thank you. And Joe, how about this one?
That's a pie.
That is a pie. And then Sid, how about this one?
Line graph.
Line graph, very nice, thank you. All right, great. So these are all I really want you to know about graphs, especially that dry mix, okay? So if you go, it may look a little different, but if you go into Schoology, okay, and you click, sorry, okay, and you click graphs PDF. I've done this in like, I don't know, well, I've done it all day. So I think this is from second block. I put all my notes on there. So just in case you were trying to write notes and you missed something, it's right here. It'll be all right here, okay? So now we're gonna switch over to accuracy and precision. So if you want to pull up your Google Notes, that's right here in the Schoology folder, you can pull that up or whatever. So see, this is all right here, okay? All right, so now we're switching over to, still in the graphing folder. And now we're in this accuracy and precision notes, all right? And it looks like an assignment, but it's just open in your own set of notes, okay? If you can't open it, it's fine. Just take notes on paper and you can go back and fill it in later, okay? All right, everybody ready to start accuracy and precision?
So do I have to put the notes in there?
No.
Or can I like keep it on paper?
You can keep it on paper. You can keep it on paper, that's fine.
Okay.
I had to set it up like an assignment so that everybody gets their own copy if they want it. That's all. Okay. All right. So let's go to accuracy and precision. All right. And this will be how we finish out class. All right. So accuracy and precision. Sorry, I'm erasing stuff from last class. All right, so accuracy, I'm gonna turn my iPad so we can see this better. It's rotating. All right, accuracy and precision. Now, a lot of times people use these words interchangeably, but they really are two different things, okay? And I'm gonna tell you how to tell the difference between these two. So your quiz that's due on Wednesday will be over graphs and accuracy and precision. So this first blank says, blank refers to how close a measured value is to an accepted value. And there's a couple of different ways you can, when I say accepted value, there's a couple of different ways you can think of it. So you could say a book value, or the true value, or the official value, okay? So it's kind of like, all right, if you run a race, okay? If you do cross country, or you do track, or you are running your 40 for football, whatever it is, okay? And if you say, tell your friend, hey, time me, okay? But then the meet or the officials also time you, your friend timing you would be the measured value, okay? So that would be the measured value. That's the one like, okay, your friend used, they use their watch or their phone to time you. But the book value or the true value, the one that's gonna count is the ones that the officials took, okay? So if you're looking at how close a measured value is to the official value, we call that accuracy, okay? That's how accurate you are. So we would say if your friend had the exact same time as the official, they were pretty accurate. They got the exact same time, okay? If you took a test for me tomorrow, you do not have a test tomorrow, but if you took a test for me tomorrow, how would you know if you were absolutely, and I gave you your test back, how would you know if you were absolutely accurate on everything? How would you know that?
You can make 100.
You can make 100 on the test, right? If you made 100 on the test, that's accurate. You can't get any more accurate than that, okay? So you could say if you made a 90, you were pretty accurate, right? You're not completely accurate, but you're pretty accurate as well, okay? Now, that's accuracy. Precision, on the other hand, okay, the biggest thing about precision is you have to have more than one measurement for you to be precise, okay? So I'm gonna make a note of that. Must have more than one measurement to be precise. Must have more than one measurement to be precise. Okay. So back to the test. I can't make a 100 on a test and say, you know what, I was very precise. No, okay. For me to be precise, I would have to say, I took 2 or more tests. I took 3 tests, 4 tests. Let's say we have 4 tests this semester. I would be precise if I made an 82 on the first test, 84 on the second test, an 81 on the third test, and an 80 on the fourth test, right? That's pretty precise. Every single time I take a test, I make a low B. That's precise, okay? You have to have more than one measurement to be precise, okay? Now, if I wanted to be precise and accurate, I can make all A's on my test or all 100s. Then I'm very precise and I'm very accurate, okay? So precision has to do with how many times you are able to replicate, okay? If you play basketball, okay, and you shoot your free throws, but they always swing to the left, you're precise. They always go to the left, but you're not accurate because it's not going through the hoop, okay? That's precision. So let's look at these little targets down here, all right? So here we have one measurement, okay? It cannot be precise because there's only one, but we know that we like to hit the bullseye, and that's where it hit right here in the center. So this is very accurate, okay? All right, down here, I've got 3 measurements, 1, 2, 3, okay? they're not at the bullseye, so they're not accurate, but they are all kind of in the same area. So they are very precise, right? It's almost like if you have some type of instrument here. For example, okay, so let's say, let's say like a couple months back, me and my husband went to the shooting range, okay? And I was trying to hit the target, like here in the chest, right? But I kept hitting the shoulder. But every single time it was right here in the shoulder. So I was really precise, but I wasn't accurate because I kept hitting the same spot, okay? So same spot, if you have multiple measurements, precise but not accurate. Right here, they're all hitting in the same spot. These are accurate and precise. You got 3 measurements and they're all on the bullseye. Okay, accurate and precise. And then on this last one, they're just all over the place. All right, this person has no idea what they're doing. They can't hit the bullseye. They can't even hit in the same spot twice. They are not accurate and they are not precise. Okay. All right. We understand the difference between accuracy and precision. Hopefully. Okay. All right. So we're going to talk about accuracy and precision some more, but with numbers. All right. And this is how we're going to close out. So we're going to skip these definitions for now because I want to focus on this chart. Okay. All right. So looking at this chart, I'm going to ask you a couple questions. I want you to kind of look through it for a second. For now, let's ignore this section, and this section. So don't pay attention to those right now, okay? Everything else I want you to look at. Let's see if we can figure out what this test is even doing, what they're even doing, okay? So take a few minutes, look at what's left, okay? And then I'm gonna ask some questions about it, okay? Take like a minute or two. All right. Faith, can you tell me, could you look at this and tell me how many students there were? And you can either put it in the, if you can unmute or put it in the chat. I'm just trying to figure out how many students there were. You there, Faith? All right, let's do Isaiah. How many students you think?
What?
How many students?
I don't know.
Wait, did you say something? I'm sorry, I might have missed it.
Oh, I said I don't know.
Don't know? You can't look at the chart and tell? Eric, can you tell how many?
I forgot.
You forgot?
There are 3 students.
All right, Eric, tell them how you know there's 3 students.
Well, it says student A, which would be 1 student, student B, which would be another student, and then student C, and they each had 3 trials.
Very nice. Thank you. And you answered the next question. I was going to ask how many trials did each one have? So yes, they each had 3 trials. You got 3 students and they had 3 trials. All right. Can anybody figure out what were they trying to figure out?
Density average.
Yes, they were trying to figure out the density. Anybody know what they were trying to figure out the density for? They were looking for the density. What were they looking for the density for?
It looks like a liquid.
It kind of, well, maybe a liquid. Could you give me a name of what they were looking for? I see it. It's written on there somewhere.
S word, but I don't know how to pronounce it.
It is the S word. Anybody see the S word?
Sucrose? What?
Sucrose. It's sucrose.
Sucrose?
Yeah, so it's right
Sucrose.
here. It's sucrose, and this is just the science term for sugar. Okay, so it's just a science term for sugar. All right, I'm going to push through this. So here we go. Everybody know how to calculate average. How do you get the average?
You get all your data and divide it by how much data you have.
Very nice.
So if you have like 4, you add it up.
All right. So we have, these are the averages here. Okay. Let me let in whoever just, who just came in. Okay. All right. So here is, there are 3 averages. Okay. Come on, come on. We're almost done. All right. So here are their trials. Okay. Here's the trial for student A. Here's the trial for student B. And here is the trial for student C. We're almost done. Okay. All right. Here's my first question. Okay. What was the book value or the official value for the density of sucrose or sugar? What was the official value? Anybody know? It's on there somewhere.
$1.59.
Yes, very nice. It's right here. This is the official value or the true value. Okay. So now if we compare, okay, and I'm trying to push through this because it's on your quiz. We're almost done. All right. If we compare the averages of all these students, so you got an average here, an average here, and an average here. We're just looking at the average. Who was the most accurate? So who had the value closest to the book value?
Student A.
Student A.
Very nice, student A. So the official value is 1.59 and student A's was the closest. So he is the most accurate. Now, most precise, what has to be true when we're doing precision? You gotta have what?
More than one.
More than, very nice, more than one. So now we're looking at the boxes that have the 3 right here. Look carefully because I've tricked somebody every single class. Who is the most precise?
Student C.
First class that got it right. Yes, student C. They are the most precise. Okay. So student A, they're pretty close, right? But student C is really close. Okay, so they're the most precise. Okay, so you'll have questions like this on the quiz. Any questions?
Do we turn this in?
No, you don't have to turn this in. This is your notes to keep.